So our primary mission here is satellite validation, right? So we just launched this next generation system, and in order to validate its performance independently, we've got our aircraft sensor with well-calibrated instruments, and we use that to give us high confidence. So we're flying really high in the atmosphere, and it gives us very good comparisons to what the satellite's seeing.
Today we're doing a mission, wheels up from Warner Robins, Georgia. Geostationary Lightning Mapper instrument itself is an optical instrument, and we have virtually no other optical measurement to corroborate what the GLM is seeing, except for an instrument that we've developed for the airplane. And so we're looking down on cloud top at lightning.
Some things that we've shown is that if you're able to incorporate lightning into a forecasting environment, we can do things like increase lead time before severe weather hits, decrease false alarm rates, so we're able to forecast severe weather a lot better, which of course means time and maybe more importantly, saving lives.
So we don't know where the lightning originated. So the GLM is giving us where the flashes are beginning and where they're propagating, and then with the ground-based you can tell where they went to ground. So if you're, say, at an airport, baggage handling, fueling, you're outdoors, you may not realize that you have a non-zero risk above you with the lightning propagating overhead or coming from some distance away. And so the GLM can help us to pick that and improve your situational awareness.
You know, since last fall, we've been hearing Dan talk excitedly about a weather satellite called the GOES-R.
Right. When it launched into space in November, Dan got a special invitation from NASA to be there, and he's here now to tell us more about the satellite, what makes it so special. And Dan, this is called the GOES-16.
That's right. It got a number instead of a letter once it was sent into orbit, and now the GOES-16 is being checked out. A new era in weather forecasting is just about to begin. Let me tell you, it was quite a sight, and for we meteorologists, it was a heart-stopping moment. Thanks to a NASA invite, I had an up-close look at the GOES-R launch at the Kennedy Space Center in Florida last November. It was a perfect launch, and once in orbit, GOES-R gets a number instead of a letter. It's now called GOES-16. The new satellite's ability to measure clouds, temperatures, and track winds is very important because we have to tell numerical weather models what the weather is doing right now to make a good future forecast. Weather satellites fill in the data gaps over the oceans and high in the atmosphere, and GOES-16 will lead to much more reliable, longer-range forecasts. I've saved the best for last, though. The new lightning detector on GOES-16 will see all of the lightning and storms, and in real time. Right now, we can only detect cloud-to-ground strokes, which are not really good severe weather indicators. I was part of a NOAA experiment that showed that when the total storm lightning suddenly increases, the storm often gets much stronger a few minutes later. This should increase tornado and severe storm warning times. The old GOES satellite sent back 4 images an hour. GOES-16 will send an image every 5 minutes, and when a big storm is underway, we'll get a high-res local image every 30 seconds. Weather satellites will soon be more real-time than the weather radar on your smartphone. The new era in weather forecasting is here. Now, the new GOES-16 satellite is still being tested. I saw some data from it today. It's still being calibrated, but we're probably going to start to see some real-time images, and I'll be able to show them to you late spring, maybe late May.
All right. Thank you, Dan. Look forward to it.